Hello friends, estimating the quality of clustering with Silhouette scores. Now in our previous sections we have learned about clustering algorithm, that was your k-means algorithm and shift-mean algorithm, mean-shift algorithm. So these were the algorithm for creating clusters of our dataset. And now we are estimating the quality of clustering. So what we will use here, Silhouette scores. Now how can we use that? The data in the real world is huge and messy. You know very well that our data set in the real world is very huge and messy. You can say there is more traffic in our data. So we need a way to quantify the quality of the clustering. So we are needing a way that quantify the quality of clusters. Silhouette refers to a method that is used to check the consistency of clusters in our data. It will give an estimation of how well each data point fits with its cluster. So, Silhouette will give you an estimation that the data point present in the dataset is related with its cluster. So, how much it is related with its own cluster. Okay, so let's see what is the internal mechanism in Silhouette. So, Silhouette score is a metric that measures how similar a data point is to its own cluster as compared to other clusters. So other clusters, that is your neighbor clusters, and own cluster, that is data point is a part of that cluster, is its own cluster. The Silhouette score works with any similarity metric. Now clusters are drawn on the basis of metric, that is example Euclidean distance. So the Silhouette will work on any similarity metric you can take. Okay, so the Silhouette plot will display a measure of how close each point in one cluster is to points in the neighboring clusters, and thus provides a way to assess parameters like number of clusters visually. So we have to draw a Silhouette plot, and that plot will display the measure of closeness of that point with its own cluster. So this measure will have a range of -1 to 1. So what is the meaning of that range? Let's see. First, see the formula for calculating Silhouette score. So what is that formula? That is your P minus Q divided by a maximum of P comma Q. Now, what is P and what is Q? So P is the mean distance to the points in the nearest cluster that the data point not a part of. Then that you can say they are your neighbor clusters, and Q is the mean intra-cluster distance to all the points in its own cluster. So you will calculate the distance to every data point in your own cluster, and then you will calculate average. Then that will become your mean intra-cluster distance to all the points in your own cluster. So that is your Q related to own cluster, and that is your P, that is your related to distance related to neighbor clusters. So that was your formula. So using that formula we can calculate Silhouette score for our data set. Next, the value will range between -1 to 1. Now, what is the meaning of that number? A score closer to 1 will indicate that the data point is very similar to another data points in the cluster, and a score closer to -1 will indicate that the data point is not similar to the data points in its cluster. So what is our requirement? Our requirement will be 1, that is closer to 1. So closer to 1 will give a good quality of your data set. Now if you get too many points with negative Silhouette scores, then we may have too few, or you can say too many clusters in our data, because our data point will not related to the data points in its own cluster. In that case you will get negative Silhouette scores. So in that case either we have too few, or we can say too many clusters. So for getting the optimal number of clusters, we need to run the clustering algorithm again. So if we are getting negative scores, then we have to run our algorithm again to find the optimal number of clusters. Okay, so let's see program in which we are calculating Silhouette scores for different number of clusters, and then we are plotting a graph which will show that the Silhouette score will be maximum for the optimal number of clusters. So let's see this program in Python.